Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, here is Mrs. Saira Jamal, lecturer in chemistry, with my 11th video lecture. And in this lecture, we will do the think tank of chapter number 10. And also, we will start chapter number 11, that is organic chemistry. Let us do the think tank first. Question number 17. What is true about the relative concentration of hydrogen ions and hydroxide ions in each kind of solution? For acidic solution, hydrogen ion concentration is always greater than hydroxyl ion concentration. For basic solution, hydroxyl ion concentration is always greater than hydrogen ion concentration, and for neutral solution, concentration of hydrogen ion and hydrogen ions are always same. Question number 18. Codeine is a commonly prescribed painkiller. It dissolves in water by the following reaction. Reaction is given. Codeine, when react with water, it will accept a proton to form codeine ion and hydroxyl ion, because water will donate proton and codeine will accept that proton. So we have to identify that either codeine is a Bronsted Lowry acid or a base. So from the reaction, it is clear that codeine, by accepting proton from water, is converted into codeine ion, hence is Bronsted Lowry base. Question number 19. Suggest some ways in which you might determine whether a particular water solution contains an acid or a base. So there are several ways to identify type of solution. Some important ways are litmus test, indicator method, pH paper, and by using pH meter. The first method is litmus test. So you know that acid turns blue litmus paper red and shows no effect on red litmus paper, while bases turn red litmus paper blue and shows no effect on blue litmus paper. You can see in this image that the acidic solution turns blue litmus paper red and basic solution turns the red litmus paper blue. And in the third beaker we have a pH paper. By dipping pH paper in a solution, the pH paper will show some specific color, and by comparing that color with the scale, we can identify the pH. Suppose this purple color show that the pH of the solution is 12, and as this pH is greater than 7, pH greater than 7 means that the solution is basic in nature, and pH less than 7 means that solution is acidic in nature, and pH 7 is neutral solution. So by using pH paper, we can also identify about the nature of a solution, that either it is acidic or basic or neutral. Indicator method. Indicators are chemical compounds that tell us whether a substance is acidic or basic by changing its color. For example, phenolphthalein is an indicator and it turns colorless in acidic solution and pink in basic solution. In this image, you can see that at pH less than 7, the solution is acidic in nature and the color of phenolphthalein is colorless. While at pH 8, the color of phenolphthalein is light pink. And at a pH greater than 8, the color of phenolphthalein is dark pink. So phenolphthalein turns from pink to colorless in acidic solution and from colorless to pink in basic solution. pH paper. The third method is pH paper. pH papers are strips of paper that changes color depending on the pH, means the acidity and alkalinity of a liquid, and by comparing the colors with pH scale, one can identify the nature of solution. pH less than 7 is acidic solution, more than 7 basic, and of 7 is neutral solution. The last method is pH meter. pH meter is an electric device used to measure acidity and alkalinity, means hydrogen ion activity or pH of solution. It gives us accurate result. This is pH meter, and by dipping the pH meter electrodes in solution, the reading is 9.84, which shows that the pH is greater than 7. So this solution is basic in nature. Question number 20. The table below shows the colors of two indicators in acidic and alkaline solution. We have two indicators, A and B. The color of A in acidic solution is red and in basic solution is blue, while indicator B is colorless in acidic solution and red in basic solution. So the first question is, what will be the color of the indicator A when pH of solution is 3? So pH 3 is acidic pH, and we discussed it here that indicator A in acidic medium like pH less than 7 is red in color. So what will be the color of indicator A in a solution of pH 3? pH 3 is acidic in nature, therefore the color of indicator will be red. And indicator A at in alkaline solution is blue in color. So in a solution of pH 10, the solution is alkaline in nature, therefore the color of indicator A will be blue. Indicator B, what will be the color of indicator B in a solution of pH 5? And we discussed it in the previous slide that indicator B is colorless in acidic solution. So as pH 5 is less than 7 pH, it means that the solution is acidic and will be colorless. And when a few drops of indicator B are placed in a solution X, it turns red immediately. We know that indicator B is red in basic medium. So as by putting indicator B in a solution, it turns red, means that that solution is basic. That's why the indicator B changes color from colorless to red. What can you deduce about the properties of solution X? We can say that the solution is basic in nature because indicator B has red color in alkaline medium or in basic medium. The properties of a base or a solution which is basic in nature or alkaline in nature is the taste of alkaline solution is bitter. The alkaline solution, they shows no effect on blue litmus paper, but they turn red litmus paper blue. They harm skin tissues, and in aqueous solution, they are good conductor of electricity. Are these five are the properties of alkaline solution or basic solution? Question number 21. Bacteria in our mouth feed on small particles of food stuck to our teeth and change it into acid. Explain how using toothpaste of pH 10 can help to prevent the acid from damaging our teeth. So toothpaste of pH 10 means it is pH is greater than 7, so it means it is alkaline. And that alkaline toothpaste helps to neutralize the plaque acids which cause to decay. So the acidity in our mouth or in our plaques, they are neutralized by the alkaline toothpaste and then prevent our teeth from decay. Question number 22. Can a substance be a Lewis acid without being Bronsted-Lowry acid? And answer is yes. Bronsted-Lowry acids are only addressing the release of hydrogen ion. Like we can say that that species which can donate a proton is called Lowry Bronsted acid. But the proton hydrogen ion itself can act as a Lewis acid because it is electron deficient and can accept a proton. So hydrogen ion by itself is a Lewis acid where electrons are accepted from donor species. Example, it means that hydrogen ion, which is proton itself, is Lewis acid, and boron trifluoride is a common example. It is a Lewis acid but does not have any hydrogen, so it cannot be a Bronsted-Lowry acid because according to the Bronsted-Lowry acid, an acid is a species which can donate a proton. But boron trifluoride does not contain any proton. So it is a Lewis acid but does not have any hydrogen or any proton. So it cannot be Bronsted-Lowry acid. It is Lewis acid but it cannot be a Bronsted-Lowry base, Bronsted-Lowry acid. Now, dear students, we have completed chapter number 10. Now we are going to start chapter number 11, that is about the organic chemistry. Very interesting chapter. And the major concept of this chapter are we will study the organic compounds. We will study about the sources of organic compounds, the uses of organic compounds, alkanes and alkyl radicals, and functional groups. All these topics we will study in this chapter, that is chapter number 11, organic chemistry. Let us start the chapter. The first topic of this chapter, that is the branch of chemistry, which is called organic chemistry, and all of you are familiar about the organic chemistry, that the branch of chemistry that deals with the study of carbon containing compounds, which are also called organic compounds, and their properties. However, there are few compounds of carbon such as carbon dioxide, carbon monoxide, carbonates, and carbides. All of these compounds contain carbon, but they are considered to be inorganic substances. Why? Because they have totally different properties than organic compound. Their properties are different from organic compound, and in their properties they resemble inorganic compound. So although these compounds contain carbon, but they are inorganic compounds due to the similarity in their properties with inorganic compounds. They are classified as inorganic compounds. Examples of organic compounds, we have many examples of organic compounds. Some important examples are coal, natural gas, petrol, carbohydrates, proteins, lipids, enzymes. These are natural or like the examples of the living things. And then we have plastics, rubber, synthetic fibers, paints, glue, varnishes, artificial sweeteners and flavors, drugs, dyes, soaps, and detergent. All these compounds are organic in nature, or they are called organic compounds. What are organic compounds? Carbon containing compounds are called organic compounds, and carbon is an essential constituent in combination with hydrogen, oxygen, nitrogen, sulfur, phosphorus, and halogen. It means organic compound, they does not only contain carbon, but in addition to carbon and hydrogen, They also contain some other elements, like they also contain oxygen, nitrogen, sulfur, phosphorus, and halogens. And they may also contain some metal atoms. You can see that this is the formula of acetic acid. So in addition to carbon, this organic compound also contain oxygen and hydrogen. Same in urea, in addition to carbon and oxygen, this compound also contain nitrogen and hydrogen. So organic compound which contain only carbon and hydrogen. There are some organic compound which only contain carbon and hydrogen, and they are called hydrocarbons. For example, methane, and we have another example of ethane. So methane, ethane, they contain only carbon and hydrogens in their formula, so they are called hydrocarbons. Organic compounds can also be defined as the hydrocarbons and their derivatives. Hydrocarbons, I told you, the carbon and hydrogen containing organic compounds, and derivatives mean a compound which is derived from a similar compound by chemical reaction. You can see that we have a compound methane which react with chlorine and will form methyl chloride. It means methyl chloride is a compound which is derived from methane, and it is same like methane with little differences. And this methyl chloride is formed of methane. So methyl chloride is the derivative of methane. So derivative of methane is methyl chloride. There are more than 10 millions of organic compounds, and why we have so abundantly organic compounds in our nature or in our surrounding. There are some reasons behind their diversity or large amount of organic compound in the surrounding. So the existence of such a large number of organic compounds is due to the following reason. The first reason is catenation. What is catenation? The self-linking ability of carbon to form long chain and rings is called catenation. It means self-linking ability means that carbon will make bonds with other carbons and will form long chains. You can see in this case we have one, two, three, four. Four carbon atoms combine together along with hydrogen and will form long chain. And as it has four carbon atoms, so we will use atom butane. But comes from four. So four carbon atoms are there. So the name of the compound is butane, and they can also form rings. So you can see one, two, three, four, five, six. So it is called hexagon. So it is six carbon containing compound, and as it is in the ring form, so it is called cyclohexane. Hex comes for six. So it is composed of six carbon atom. That's why it is called cyclohexane. So the self-linking ability of carbon to form long chain and rings is called catenation. So due to the process of catenation, carbon has millions of compounds. This is chemical diversity and magnitude of organic compound. Reason, the first reason was catenation. The second reason is isomerism. What is isomerism? The compounds that have same molecular formula but different arrangement of atoms in their molecules are called isomers, and the phenomena is called isomerism. So for example, pentane means five carbon containing compound. So we have this is butane, one, two, three, four. Four carbon containing compound. This is one, two, three, four, five. Five carbon containing compound. Here for pentane we need one more carbon atom which is missing here, one, two, three, four, and there must be one more carbon with three hydrogen, and this is two hydrogen. This is called pentane. If all the carbon atoms are present in straight line, so that pentane is called N-pentane. N means for normal pentane. And if one of the carbon atom or methyl group is in the branch form, like these four carbon atoms are in chain, and this one is present as a branch on the chain. So this type of isomer is called isopentane. There is one more isomer which is possible if two carbon atoms are present as a branch. Total are 1, 2, 3, 4, 5. So you can see that the formula, molecular formula is same, but the arrangement of atoms is different. So this type of isomer in which the carbon is surrounded by four other carbon atoms. There is no hydrogen atom there because carbon already is making four bonds. This is only carbon. Carbon attached with four carbon at the side. So this type of isomer is called new pentane. This means that three compounds have same molecular formula. As the number of carbon atoms in an organic compound increases, the number of possible isomers also increases. So there are three isomers of pentane. Next reason is strength of covalent bonds of carbon. Due to its smaller size, carbon can form very strong covalent bonds with other carbon atoms. And like with hydrogen, with oxygen, with nitrogen, and even with halogen, carbon can make strong covalent bond. So due to this property of carbon to make strong covalent bonds with the other atoms. This enable it to form a large number of organic compounds. Example of carbon to make bond with oxygen is methanol. You can see CH3OH. It means in this case carbon is making bond with oxygen and hydrogen. So or with hydroxyl group. So this type of compound where carbon is making a strong bond with other atoms as well, like with oxygen as well. So this is also one of the reasons that we have millions of organic compounds in our surrounding. And the fourth property of carbon to have millions of organic compounds is multiple bonding. It means that carbon can make multiple bonds like double and triple bonds. So you can see that carbon has the property of making multiple bonds. It can make double bonds and the two carbon atoms can make triple bonds with each other. Next topic is about the general characteristics of organic compounds. Characteristic mean properties of organic compound. The first property is occurrence. Where are organic compounds present? So most of them come from living things that were once living. For example, coal, petrol, and natural gas. They came from the dead and remains of the plants and animals which are buried under the earth crust, and after millions of years due to high temperature and pressure under the earth, they are converted into coal, petrol, and natural gas. So most of these organic compounds come from living things that were once living, and now we can also prepare even organic compounds in lab, like urea is one of the examples which we can artificially make. Second property is covalent nature. Organic compounds are generally covalent in nature, and we have two types of covalent compounds, polar and non-polar. So some are polar and some are non-polar organic compounds. The third property is composition. As I told you that organic compounds mainly are made up of carbon and hydrogen, but along with carbon and hydrogen, other elements like oxygen, nitrogen, sulfur, phosphorus, and halogens are also present in many of the organic compounds. Next property is melting and boiling point. Generally, organic compounds are volatile, so they have low melting and boiling point. Volatile, I told you that those substances which can convert into gases at room temperature. Next property is solubility. So organic compounds are non-polar in nature except some. Therefore, mostly they are soluble in organic solvent because like rule said that polar solute can dissolve in polar solvent and Non-polar solute can dissolve in non-polar solvent. So as organic compounds are, majority of organic compounds are non-polar, so they are soluble in organic solvent, which are also non-polar in nature. Uh, for example, ether, benzene, carbon disulfide, they are organic solvents. Polar organic compounds are soluble in alcohol, such as methyl alcohol and ethyl alcohol. Like they are polar in nature, so it means that polar compounds can dissolve in methanol and ethanol. This is ethanol or ethyl alcohol. Next property is similarity in behavior, which is also called homology. We can say that there exists a close relationship between different organic compounds. This similarity in behavior has made the study of millions of organic compounds easier. They can be classified into few families. A series of organic compounds in which any two adjacent molecules differ by a CH2 group is called homologous series. Homo means same, so same behavior is present in many of the organic compounds. We will discuss some family in our next lecture, inshallah, that we have some, we can see families of organic compounds, and organic compounds are classified in those family on the basis of similarity in properties, and one group differ from the other group only. They have one carbon and two hydrogen atom different. The seventh property is reaction rates. So organic compounds are generally less stable than inorganic compounds. So due to covalent bonding in them, the reaction rates are often very slow. Organic compounds are generally less stable than inorganic compounds. So due to covalent bonding in them, because covalent bond is a weaker bond than ionic bond, so ionic compounds are more stable and have high reaction rate than these inorganic compounds. Sorry, than organic compounds which have covalent bonding in them, and their reaction rates are oftenly very slow due to that covalent uh, bonding in them. Next topic is about the chemical formula. A chemical formula is an expression that states the number and type of atoms present in a molecule of a substance. We have different types of chemical formulas. The first one is molecular formula. For example, molecular formula of benzene is C6H6. Empirical formula of benzene is CH. And about these two formulas, you have already learned in in the previous grade 9. Now we have to learn the two new types of chemical formulas, and those two types are structural formula and condensed formula. So structural formula, a formula that describes the arrangement of atoms in a molecule. Frequently, more than one organic compound is represented by the same molecular formula. However, they have different properties and different structure. Their molecular formulas are same, but their structure is different and their properties are different. So you can say that they are called isomer because this is the definition of the isomer, that the compound which has same molecular formula but different structures or different arrangement of atoms are called isomers, and the phenomena is called isomerism. So it means that these compounds, they have different properties and different structure formulas, but their molecular formulas are same. We have an example. Example is, if you see this, we have two carbon atoms and one, two, three, four, five, six hydrogen atoms and one oxygen atom. So C2H6O is the molecular formula for ethanol, which is an alcohol. And again, if you see here, one, two carbon atoms and three, six hydrogen atom and one oxygen atom. This compound is also C2H6O. Both compounds have same molecular formula, but the arrangement of atoms are different. Here, oxygen is present at the side of two carbon atoms, while in this case, oxygen is present in between the two atoms. So, arrangement of oxygen atoms and hydrogen atoms are different. So, those type of compound which have same molecular formula, but the arrangement of atoms are different, or in other words, you can say that they have different structures. They are called isomers. So this one is ethanol, and this compound is called dimethyl ether. Dear students, hope you will understand this lecture. Inshallah, in our next lecture, we will continue this types of chemical formula, and inshallah, we will do the condensed formula. Till then, take care, Allah.